cares what the lengths of the two vectors multiplied together is, right? Who cares? That's not what makes the dot product so good, all right? We're still building up to why it's such a valuable thing. Why is the dot product so important?
I forgot.
Oh, no. Oh, no. Okay. I have 8 minutes? Okay. Well, I'll be quick. All right. So if the angle between them is 0, we have that it's just the lengths of the two vectors multiplied together. Okay, there you go. Good. I'm glad it's in there. Now, what if the angle between them is pi over 2? 90 degrees. Cosine of 90 degrees is 0, which according to that formula would mean that the dot product would be magnitude of u, magnitude of v, cosine of pi over 2, which is 0, which means that the dot product would have to be 0, wouldn't it? This means if the dot product of two vectors is 0, we can say the vectors are perpendicular. Another word for perpendicular is orthogonal. And it turns out that there is another theorem that you can prove, and this is the main result. This is the big deal when it comes to dot product, is that if you have two vectors and you want to know if they're perpendicular to each other, all you have to do is compute their dot product. If the dot product is 0, they are perpendicular. It's a way to check for what we call orthogonality, which is perpendicular. Understand? You sure? Super useful. I won't get into the rest. We'll have to cut this short, but I want to at least motivate the idea a little bit. Okay, let's say that we have a triangle. Starts here, goes up, comes down. I say that's 5, that's 4, and that's 3. My question is this a right triangle?
Yes.
Why?
Well, if you don't have the symbol there, so I don't know.
I didn't put the symbol in there.
3, 4, 5.
Because it's 3, 4, 5?
Special triangle.
And that's a special triangle. It is, or there is a 90-degree angle in here, right? Okay. Where's that 90-degree angle? Right in there? Yeah. Okay. I'm going to prove that that's a 90-degree angle with the dot product. All right? So here's how I'm going to prove it. I'm going to create two vectors right now. I'm going to create a vector that goes from here straight up to here, and a vector that goes from here straight over here. I'm going to call this one V, call this one U. Okay? Can somebody tell me the components of U? So left and right, do we have anything?
3.
Nothing, right? Left and right. So 0, and then the y component, 3. Yes? Now, let's take the vector v.
4, 0.
This is the vector -4, 0. Because you start here, it's pointed to left 4, nothing up and down. Right? If I dot those two, if I take u dot v, then that's going to be 0, 3, dotted with -4, 0, right? Then I get, you do these two together, which is 0, plus these two together, which is 0. And you get 0. And if the dot product is 0, that means that that angle is 90 degrees. With me?
Why is it -4?
Because the vector, you start from here, and we're saying, you know, what is its x component? It's to the left 4, right? Because look at the arrow here.
If it was to the right, it would be positive.
If it was to the right 4, it would be positive, yes. But because of the way I drew the triangle, I was trying to check for this angle, right? So I need to start here, create a vector up and a vector over. So I'm talking about the angle between the two. Yes? Now, had you done the vector the other way, like this, you would have been able to tell me that this angle is 90, which would imply that that angle was 90 also. But you would have been checking this angle as opposed to this one. Now, you may still be looking at that going, well, that's not very, big deal, right? Big deal. But now think about this. What if I give you this point 1, 1? give you this point up here, 2, 5. And I give you a point over here, 7, 3. Okay? And I say construct a triangle. Now you might trust your drawing or not trust your drawing, but my question is this a right triangle? Maybe? No, I don't know. I mean, maybe from the picture you're not convinced, okay? But what's one way I could check it to see if it's a right triangle or not? What I could do is I could just check this. I could check each angle, couldn't I? So if I wanted to check this angle, I would have to create a vector that goes from here to here, and a vector that goes from here to here, and then dot them. If I get 0, it's a right triangle, and I'm done, because only one angle can be 90 in a right triangle, right? If I dot them and I get something other than 0, then that's not a 90-degree angle. And then you move on to the next angle, which means you create 2 more vectors and dot those. And if that's not 90, you move on to the third one and you dot those. Does that seem tedious? But this works in 3-dimensional space also. So if you have 3 points in arbitrary space, 3-dimensional space, and connect those with a triangle in 3-dimensional space, doesn't matter how it's oriented, you can check to see if it's a right triangle, which is pretty fantastic, because it would be very difficult to do without the dot product. I mean, like analytically by hand, that would be tough. I mean, you could try and do this another way. All right, let's see if you could tell me what this vector is. I'm going to call this one U, and I'm going to call this one V. This is calling on stuff from 2 classes ago, so I know it's going to be maybe something you can't recall. But do you remember how you get the vector between 2 points? Like from here to here? You do some sort of subtract, right?
A2, A1, subtract, plus, is that right?
So, well, yeah, I think.
And then B1.
It's the terminal point, the one here. Take away this point. So our vector U should be, what? You're going to take the x-coordinate here, 1, subtract 2, and you get -1. And then take 1 and subtract 5, and you get -4. That's our vector U. What's our vector V? Goes from here to here, right? So what is it? 5, -2. So you're going to go 7 minus 2, that's 5. And then 3 minus 5, which is -2. That okay? Dot these together. So what would you get if you did U dot V? You get -5 plus 8. Almost. It's 3. That's not 0. Okay, so this is not a right angle. See how quick that was to check that, though? I mean, once you understand how to create the vectors, do you see how fast that was for me to check to see if that was a right angle or not? And then I could do, to check this angle, right? If I want to know this angle, I could create these 2 vectors, which would be basically like the opposite, like going from here to here. What would this vector be? From here to here. 1, 4, right? So that vector, I'm just going to label it. This is the vector 1, 4. What's this vector here? So 6, 2. And if I dot those, 6 plus, right, it would be 1 times 6, which would be 6 plus 8, 4, it's not 0. So that wouldn't be, this is not a 90, right? And then unfortunately you would have to check the last one. It's not. Okay. So very quick way of checking to see whether or not 2 vectors are orthogonal. And I think we'll end it with that. Okay, let's talk test. We have about 30 minutes. So I want to start off with any questions. I know some of you have been working through those problems. I think I'll put a bonus question on the test on dot products. Okay? What was your question? Which one was it?
So say 57 on 10-4.
10-4. 10-4. And number 57. If this, find the numbers for which all that stuff? Okay. So this number 57, 10.4. Number 57 says if V is equal to 2I hat minus J hat, W is equal to XI hat plus 3J hat. Find all X such that they use double absolute value bars. And I told you that that was the same as the magnitude, right? Such that the magnitude of W, V plus W is equal to 5. Okay, first things first. I told you I don't like the IJ notation. So let's just all be clear that this is really the vector 2, -1. That's the same thing. And then what is this vector? Well, we don't actually know what this is, do we? It's x. So this is x comma 3. All right? Okay, can you tell me what v plus w is? Just v plus w. So how do we add these? This is just going to be, you add up the x components, so 2 plus x, and then comma, now you add up the y components, which would be 2. We still all good? Yes? Okay. Yeah? Yeah? No? Okay. And now we want to know when the magnitude of that's 5.
Do we just equate them to 5?
We're going to do the length of it equal to 5. Yes. So what is the length of this vector? Square root of each of these things squared and added together. So 2 plus x, quantity squared, plus 2 squared equals 5. This is what we want, right? We want to know when is this true. Okay. Well, let's go ahead and just figure out what all this is in here. What's 2 plus x squared and then plus 2? X squared plus 4x. So x squared plus 4x plus 4, right? That's what this would be. But then plus 4 again, so that'd be plus 8 equals 5. So I'm trusting that you could expand that out, get x squared plus 4x plus 4, then add 4 to it again and get 8. So we got root of all that stuff must equal 5. And we're trying to solve this for x, right? So this is a radical equation. How do you solve radical equations?
Accurate?
That will happen. Not yet, though.
Square both sides.
Square both sides. Whenever you have square root equations, you want to isolate the root and then square both sides. So I have this root. It's isolated. Square both sides of the equation. Now, because I squared both sides of the equation, what am I going to have to do at the very end? Check for extraneous solutions. You're thinking if I square root both sides. Yeah, if I square both sides, I just have to check for extraneous solutions.
Yeah, because one of them's not going to be very good. Probably.
They could both work, but most likely they're not.
Yes, and most likely you're going to get that one that works. Another one's going where are you out there?
Exactly. So I subtract 25 on both sides, and I get negative 17 equals 0. And now you have a quadratic equation which you can try and factor. If it doesn't factor, use quadratic formula. And my guess is that that does not factor. It doesn't. Yeah. What? It says, oh, okay. Yeah, just because this is prime doesn't mean it doesn't factor. But yeah. Okay, so we have to use quadratic formula. Yep. Okay, so the quadratic formula says that the solutions to that will be negative b plus or minus the square root of b squared, which would be 16 minus 4 times a, which is 1 times c, which is negative 17, all over 2 times a. I'm assuming you've had some intimate meetings with this formula already, that y'all are well acquainted. Yes.
Know that formula.
Long time ago.
Just use it for everything if you want.
Any quadratic that'll work for.
That's what I meant, like any quadratics, you don't have to use shortcuts if you don't want to.
Yeah, you don't have to learn how to factor, but well, I should take that back. If you're solving quadratic equations, that's all you ever need. If you're trying to factor quadratic expressions without an equation, then you can still use that, but you have to be careful. But all right, what's this? 16, and then we're doing plus 40, 50, 68. So 16 plus 68, 84. All over 2. And I don't know, do they want a decimal? No, they left it in radical form.
That's the answer.
They cleaned it up a little bit more, but let's see, 84. Can we break 84 down? That's 4 times 21, right? I can break down 84 as 4 times 21. And then I can pull the 4 out as a 2, can't I? So if I do that, I have negative 4 plus or minus 2 root 21 over 2, and then I can go 2, 2, and then that turns into a 2. So negative 2 plus or minus root 21. And then I would have to check these answers. And yeah, I don't feel like it. But we know one of them is going to work. They actually both work, though. Does that help clarify the question? Okay. What else? That's it? Y'all are ready, huh?
We need to bring the book as a formula sheet, or you make
Who does not have the formulas from the back of the book? Who does not have them? It's okay if you don't. I just want to know if I need to print them or something.
Well, I mean, you wanted to bring my book, or do you want
I don't want you to bring the book. If you have the sheet, I'll bring it. I'll bring copies, okay? This is the one you can use. You can't use anything other than this. You can't be like, yeah, this is like this pre-cal from high school, this formula sheet. It has to, everyone has to be level playing field here. So everyone uses this, yes?
No sheet.
So you'll have one?
I will provide that for you. Yep,
Just want to make sure.
yep.
Bring my book.
How about unit circle? Have you finally weaned yourself off the unit circle?
Yeah.
Let's just say we have to do this.
Say somebody knows so we can do the 5-point bonus on it.
I think this time what we'll do is I'll provide I'll provide a unit circle, but it'll cost you 3 points.
And if we don't use it?
If you don't use it, then good. You're where you need to be. So it's penalty only. So I'll have them up here, and if during the test you're like, hey, I really would like that unit circle because I'm unsure about something, then you can. What about any other formulas? Let's see.
Just follow that.
Law of cosines is here. Law of sines is here. All the half angle. I mean, if you've been doing your homework and you've been using that, you can see that mostly what you need is there. So y'all don't want me to talk about homework? Y'all are like ready to bail, huh? You can go to the lab. So I gave you the list of problems out of those chapter reviews to look at, right? I did that at the end of class last time. Okay, well, I mean, I'm not gonna keep you here.
Follow those review questions that you gave us for the chapter review. We should be good.
Yeah, I have not made the test, but I'll tell you right now, I'm going to sit down and I'm going to bring up that YouTube video from the other day when I said, look at these, and then I'm going to go through those problems, and I'm basically going to make a test based on that. But now it won't be as long as all those problems, obviously.
You should be proficient.
But each topic you should be comfortable with. Yesterday's class, at the end of yesterday's class, I put up the list of the problems to look at, right?
Yeah, I'm already enrolled in this class.
Can I do what? 8.6. You're free to go. If you want to stay, you can. All right? I'm going to answer questions until people...
Did you do problem 27 on 8.5, I think it is?
Yes, I'm doing 8.6, number 31.
I think so. I think it's
F of 2 theta. Are we looking at the same thing? Which one are we talking about?
If you get on there and look right now, see it.
31, this is not 8.6. I don't think so. Wait, 31?
Yeah.
Sine of 2 theta? Okay, because F is sine. Okay, yeah, we can do that. So there's like pictures we have to go off of for this, right? Yeah. Okay.
They were the same pretty much all the way through. Yeah. Well, we showed this in the last. Yeah, they did the last. Check it out real quick. It won't take you a minute.
I mean, if it isn't, I can do it exactly at 12 a.m. if they are. Do you know if the classes open up at 12 a.m. for sign up?
I have no idea.
Okay.
Sorry. I'm not really paying much attention to it. Huh?
I said, I guess I'm going to be up late anyway, so might as well look at 12
Yeah,
a.m.
you can check it out. I don't know when all the registration stuff is. Okay, so they give you that f of x is sine of x. They ask you to find f of 2 theta, and then they give you a picture about theta. This is the only information you have about theta, right? There's another picture for beta, or for alpha. But you don't need that, right? You don't need that for
I
this.
saw the trick in this one was tricky. They tricked you, they tried to trick you in this one.
Okay. Well, first of all, can you tell me what f of 2 theta means? And I think you had that written down. F of 2 theta would mean sine of... Okay, let me ask you this. If they're telling you f of x is sine x, right? Then what would f of 2 be? What's f of 2? That would just be sine of 2, right? If I said what's f of 10, you would say sine of 10. Yes? So if I say what's f of 2 theta, it's just sine of 2 theta, right? So when they ask for sine f of 2 theta, they really want to know what is sine of 2 theta. That okay? Now, you have information about theta, not 2 theta. But you do have a formula that allows you to get rid of the 2 theta and create something else, the double angle formula, which is 2 sine theta cosine theta. Now, do you know what sine of theta is? So looking at this circle, yeah, what's tricky about this problem is that that is not a unit circle. So this is not unit length. This is not length 1. And the reason we know it's not length 1 is because of this formula right here. This right here tells us that this is a circle, and this is the standard formula for a circle. X squared plus y squared equals r squared. So what is the radius of this circle? Root 5. Right? 5 is r squared. Right? 5 is r squared. So that means r would be the square root of 5. Yes? I'm looking for nods here of yes.
See, the thing,
Yes?
the thing that fooled me about this problem was that they didn't square 5 in the problem when they showed it to you up there.
That's right, but look at the formula. This is the standard formula for a circle, right? So if I write, most students have no problem with this. If I write x squared plus y squared equals 9, people will be like, oh, well, r is 3, right? But if you write that, then people are like, oh, you know?
That's exactly what happened.
So if it's 9, it's 3. If it's 25, it's 5. If it's 16, it's 4. But if it's 5, it's root 5, right? Whatever that is. You okay with this?
Yes, sir.
Okay, so now,
You know sign now. 2 over
Do we,
5.
do we know sine?
2 over root 5.
Where are you getting that from?
Well,
By definition, right?
yeah, you know that the y value is 2, so you know that that line right there on the perpendicular is the perpendicular line of y right there. That's gonna
You know this is 2, don't you?
2 over root 5.
And you know that this distance from here to here is what, a?
It's going to be y, so then you can solve the Pythagorean stuff.
Mm-hmm.
Pythagorean theorem to solve it.
Are we good with this or not? Okay.
Negative 3.
So, sine of theta right now would be your y coordinate 2 divided by the length of the hypotenuse, which is root 5. So sine theta we've got. It's 2 over root 5. Good? Okay, now cosine theta is adjacent over the hypotenuse. And all you know right now about the adjacent is that it's a. However, you do know that this triangle looks like this. And you actually know what 2 of the 3 sides are. So you can solve for a right now. You can say a squared plus 2 squared must equal 5. So root 5 squared is 5. And that means that a squared plus 4 is equal to 5, which means a squared is 1, right? Which means a is going to be positive or negative 1, right? It's positive or negative 1. And we know it's negative 1 because you're over there. So a is actually negative 1 in the problem. Make sense? Okay, so cosine then would be negative 1 over the hypotenuse, root 5. And when you multiply this all together, it would be 2 times 2 times negative 1, which is negative 4 over root 5 times root 5, which is just 5. So negative 4/5. It's a good problem.
Did you get that? Or you went a different way?
I got negative 3 over 5.
I bet you did 2 times 2 and you
Oh,
subtracted
yeah,
1.
Yeah, the problem on that same homework, number 47, would you show that one?
Finding expression, no. I won't do that one. I would never ask you that on the test. That's kind of a torture problem.
That way, yeah.
It's kind of a torture problem. Number 47 on page 663, that's the one you were talking to me about, yeah. But you probably feel more comfortable with formulas now that you've tortured yourself with that. Maybe, no, maybe not. Or you just hate them more.
I just hate
What we got?
For 61 on the review.
Okay, hold on. You had one first though, right? Didn't you
That
have
was the one I wanted to see was 47.
47? Okay, yeah. All right. So yeah, don't worry about that.
I think it was a hell to work.
Yeah, that's nasty. What was yours now?
61 on the test review.
What page is that?
For chapter 8.
71. And you said which number?
61.
61. Cosine of arctan of 1, that one?
Yeah.
Okay. Arctan of negative 1.
What page?
This is going to be from page 671, number 61.
Use the cosine.
Okay, so I have cosine of brackets arctangent
Minus 1
negative 1,
plus cosine, arc cosine of negative 4/5.
arc cosine of negative what?
4/5.
Okay. Okay, so the overwhelming thing you need to see here is what we've talked about before, that this looks like cosine of alpha plus beta, right? So alpha is this entire expression, beta is this entire expression. And we have a formula for cosine of alpha plus beta. It would be cosine alpha, cosine beta, what? Minus sine alpha, sine beta. That would be what that formula would break down if I completely replaced arctangent of negative 1 with alpha and arc cosine of negative 4/5 with beta. Now, I've seen this done several ways. You did it one way. I kind of do another way. It's it's really kind of up to you. So you did the triangles, right?
Yeah.
So starting with this right here, you said that you could draw a triangle, and because it's arctangent, you're not allowed to look over in here, right? And you're drawing a triangle where the ratio of the y and the x is -1? Is that what you did or no?
Yeah.
Okay, so you went down into this quadrant,
Yeah.
and then did you actually assign any values for
Yeah.
these two sides?
Like -1 for the y value.
-1 for the y and +1? Okay, that's great. It works. Okay. So let's just complete this triangle just so we have it as a reference. This squared plus this squared should be 2, and then square root. So this side's root 2. In case I ever need that again, I've got it, right? Okay. This angle right here, this is the angle alpha that draws this thing.
Cosine alpha.
So everything here corresponds to alpha.
Yep.
All right, now let's do the other triangle while we're here. So the other triangle, it's arc cosine, so you're not allowed to be down here. It's negative, which means you have to be in the second quadrant.
-4.
And that means this will be -4 and this will be 5. And then you can solve this side for 3. Okay. And this is everything we need to know about beta. All right, now let's just go to this formula right here. Let's replace everything. So we have cosine of alpha. Alpha is, well, see, this is where, like, do you just want to work off the triangle now? I mean, that's really what we're doing.
1 over root 2.
Yeah, we just need to go to this triangle. Well, let me write it down. This is cosine of arctangent of -1. Because what? Oh, yes, it can. Yes, it can. But that's okay because cosine of it is a ratio.
Yeah.
It's a ratio. So if you would have done -2, 2, right? This side would change, but the ratio would stay the same. Okay? So that's that. Then I have cosine of beta, which is cosine of cosine inverse of -4/5. And then I have minus sine of alpha, which is sine of arctangent of -1. And then sine of beta, which is cosine inverse of -4/5. All right, I think I've got everything written in there properly.
So if you put that in the calculator, would you spit out the answer at you? Even if I broke it apart into 2 sequences?
Yeah, but you're probably going to get a decimal.
Yeah.
You're probably going to get a decimal. You're not going to get the well, no, because this is the answer. The exact answer is going to have roots and stuff in it, and I believe they want the exact answer.
Yeah, they do.
Yes, it's find the exact answer.
Wouldn't it be easier just to plug in the triangle
Yeah.
points?
So just remember that this right here is an angle, isn't it? This is the angle alpha. This right here is beta. This right here is alpha. This right here is beta. And so when this says cosine of alpha, we come over here, we say cosine of this triangle is what this is saying. So cosine of that triangle is what?
1 over root 2.
1 over root 2. Yes? So this right here, all of this, just 1 over root 2, times, now this says cosine of beta, so we go to this triangle, and -4, but these kill each other off too, you can look at it that way. Cosine of arc cosine, they're gone, so this is just -4 over 5. Minus sine alpha, so you go to your alpha triangle, and you're doing opposite over hypotenuse, so -1 over root 2, times sine of beta,
3 over 5.
3/5. You have to multiply these two together, and then subtract, order of operations. So you have -4 over 5 root 2.
-3 over 5.
Minus -3 over 5 root 2, which is going to be, this will be minus and minus, will be plus, right? So -1 over 5 root 2. And that would be it. Now you could go a little further, you could rationalize the denominator, but you know I don't care about that part. Let me see what the book says. Oh, the book says the answer is negative root 2 over 10.
Yep.
So they just rationalized it. They just did root 2 here, root 2 here. The bottom becomes 5 times 2, which is 10, and the top is negative root 2.
I don't have good internet at my house.
That's all right.
I had to pay freaking Hughes Dish Net to fucking rip me off every time. I hate it. That's the worst part about living in the country, dude. I miss high-speed internet so bad. I forgot what it was like.
I know, you know, I've told you we just moved, you know. Where we used to live is getting Google Fiber.
Well,
And I'm like, man.
they're bringing the Guadalupe Dish Network, not the Guadalupe, whatever it is, high speeds coming out there. So everyone's like super excited. It's like, you know, the talk of the town. It's like, we gonna get high speed internet out here. People gonna be coming from all over to live.
There's one spot remaining in your class on for the Mondays, 9 a.m.
Dude, it filled up
Really?
this semester. I don't. But the thing is, it's gonna, you know, all these people are gonna sign in. They're gonna be gone halfway through.
We're just waiting for.
I hate to say that.
For payments,
I hate to be
which is
such
in
a pessimist.
December. I think the first week of December, and then the next.
The drop will happen.
Yeah, the drop will happen.
Yeah,
and
the
then
drop.
at 7 a.m. get on and just that.
I thought it was like they drop it at like 1 p.m. and like a few minutes later you can get on.
No, it shuts off. You can't.
Till like
register
7
till-
o'clock the next morning. They'll even tell you like the system's down for maintenance. It'll say it. I've done the same thing before. Like I got kicked out of classes for not paying for them, so I had to like wait that morning. You're sitting there, you're refreshing the computer, and all of a sudden you'll see it open up, and you start clicking and punching really quick.
Just save the CRN number. So you can log in.
Exactly. Yeah. So as soon as you can pull up the ad drop page, you start typing them in, and you're done. I've learned this: don't procrastinate from getting your classes right away.
What's that?
Dude, I'm looking at this class and I'll
You did? You're taking Cal 1? That's,
If you take
you're
it online,
redoing it?